Alright guys, here are my notes on subtracting polynomials. Our goal is going to be to use some things we already know how to do in order to, obviously, subtract polynomials. Yes, we're learning something new today, but we're really just going to combine two things we already know how to do. The first thing we're going to combine, or the first thing that we need to know how to do, is how to add polynomials like we did yesterday. So I'm going to redo that real quick right here. So yesterday we saw something like this. Notice that there's a minus or a plus sign right there, and obviously that means add. So yesterday I told you guys to draw some lines down to separate your terms, and put the biggest one first. So out of all those, what's your biggest degree? Obviously x to the fourth, and these three x to the fourths are the only one, so I'm going to put that first. Then after that we're going to put some x squareds. So how many x squareds do you guys see between these 4 and these negative 2? Well, obviously there's more positives by 2, so I'm going to put plus 2x squared. Next is plus 3x. And last but not least, a 12 and an 8 make plus 20. So that's what we did yesterday. That's adding polynomials. Now how this helps is what we're doing today is super similar to it. It looks like this right here. Obviously notice that this time there's a minus sign in the middle. Here's an old state test question from a couple years ago, back when these were still on our state test. So last notes I talked about how these parentheses in the adding polynomial problems did not mean to distribute. I was lying though. Back with adding ones, we were distributing the plus sign. We're really a positive 1. That's the best way of saying what we're actually distributing. Well, here there's not a plus sign or a positive 1. What is there here? The difference today is that we're not distributing a plus sign because now we have a minus sign distributed. And let's see how this changes the problem. So if I try to change the problem right here, this minus sign being distributed out will end up making this negative 8x squared. Negative times negative 3 is positive 3x. And negative times positive 1 is negative 1. Notice how every single term in that second polynomial changed. And that's going to be what I'm getting onto on the next page right here. So distributing the negative sign changes the sign on all of the numbers after the sign. If it was positive, it's now negative, and vice versa. There's a shortcut or something that you guys can do where you don't have to distribute. And that's another topic that you guys know about. It's the whole add a line, change the sign, or McClure last year called it keep, change, change. This is going to be really what we focus on. Okay? The only difference here is that because the term after the sign is in parentheses, you need to add a line and change all of the signs. And I'll show you guys what I mean by that here in a second. Let's practice doing some keep, change, change on these 3 super easy ones. Again, all you're doing, I'll do number 1 with you guys. You keep, you change, and you change. So now it's 3 plus positive 5. So would you guys pause the video for a second, do these 3, unpause it, and then see if you get the same thing as I do. First one, you get 8. Second one, keep, change, change. There's more positives by 5. Keep, change, change. You get 15. Hopefully you guys did something similar to that, or you see what you did differently. All right, so now let's put those two things together when we subtract polynomials like this. Our goal is to always turn this into a plus sign. We want to be able to keep, change, change. So I'm going to keep, change, and I'm going to change this. And really the easiest way to do this, I should have started at the beginning. I'm going to draw those lines down again to separate. It's really important for today. Some of you guys, for some reason, still don't see why it's important. I guarantee you it's super important for today. So I'm going to keep this. I'm not going to mess with any of those. I already changed that, and in order to compensate, I'm going to change these 3. So this b squared right now, is it positive or negative? Well, obviously it's positive, so let's make it a negative b squared. We change that. This 6b obviously is positive. There's a plus sign. So let's change that to a negative 6b. And that negative 12, we're going to change to a positive 12. Okay? Remember it was the whole, sometimes teachers call it add a line, change the sign to all the things, all the numbers. All right, so now that I have that, those are my new 6 terms. Let's just go down the line because now it's just an adding problem. 4b to the third. This new negative b squared. Now I have a negative 7 and a negative 6b. It's negative 13 b's. And last but not least, I have a negative 7 and a positive 12 plus 5. Okay? And that's it. Throughout this chapter, you're going to have ones where there is a plus sign, so watch out. If there is a plus sign, you don't need to change anything. Our goal here is, again, to turn this into a plus sign. It's not, so, again, I'm going to keep change. Before I do, I'm going to draw the lines down to separate all my terms again, so it's really easy to see the positive and the negativity of each of these numbers. So let's change it. And in order to do that, again, I keep that first one, and then I change all these after. So the negative m squared becomes a positive m squared, that negative 12m becomes a positive 12m, and obviously a positive 6. So now how many m squareds do I have if I have this 15 and this new positive 1? I got 16 m squareds. How about regular m's? Plus 14 m's minus 3. That's really it, guys. On the next page, I have a couple for you to try. So again, pause your video, do them, unpause it to see if you get the same exact thing that I did. All right, hopefully that was enough time. Again, the biggest thing I would do first is draw some lines down to separate all your terms so you don't get messed up on whether they're already positive or negative, like this negative 3x is negative before I do anything. When I keep, change, and change, this change becomes negative 4x squared, positive 3x, and negative 8. So now let's start combining. How many x squareds do I have if I have this positive 2 and this negative 4? I have negative 2 x squareds. How about regular x's? If I have a negative 9 and a positive 3, I have negative 6 x's. And last but not least, I have a minus, because that's negative, and this is negative 13. Pretty easy, right? One more for you guys to check and see if you did correctly, and then I have a little curveball to throw at you. So again, I'm going to keep, change, and change, because I don't like that minus sign. I'm going to make that a plus sign. But in order to do that, I have to compensate by changing all 3 of these. So the 2 positives became negative, and then that last negative became a positive. The biggest degree that I see out of all these is that x to the third. And these are the only ones I see, so I'm going to just drop that down. Negative 2x to the third. Then I'm going to drop down this negative x squared. I'm going to combine these 2 regular x's. Now, this is confusing because this one was a plus, but it's now a minus 8x. Along with this minus 5x, because there is no reason to change that. It's not change. So it's negative 13 x's. And then last but not least, I got this positive 13, and that positive 9 is plus 24. All right, so before I did that last question, I said I have a curveball for you down here. What I want you guys to do is I want you guys to pause the video and try it without my help, and then I'll show you guys where the curveball is. So pause it. When you think you're good, unpause it, and check. All right, so hopefully that was enough time. Again, when you guys did this, I'm assuming a lot of you just did 4x squared minus 17x plus 36 minus 2x squared minus 5x plus 25. Drew your lines down, hopefully, because again, that is super important. It helps. And then kept, changed, and then changed. And if I do this, I end up getting 2x squared, negative 17, and positive 5 gives me negative 12x. And then negative 36 and negative 25 gives me positive 11. Well, that is an option, isn't it? That's 2. That's not the right answer. And on the next page, I'm going to show you guys why that's not the right answer. So let's flip to the next page. Actually, maybe not. Maybe I'm going to show you guys here. So the reason that that's bad is this word right here. Is that word from. That word from lets us know that the order is going to be mixed up. Like if I said, take 2 from 10. If you take 2 from 10, what do you get? Obviously you get 8. What do you notice about like the math sentence here? Did I go 2 minus 10 or 10 minus 2? Obviously I want 10 minus 2. That's how you get 8. So the order does matter because this up here would give me negative 8. So that being said, whenever you see that word from and they're talking about subtracting, you actually have to switch them around. You're going to start off with that 2x squared minus 5x plus 25. Keep that one and then subtract the other one. The other one's going to say 4x squared minus 17x plus 36. This is the one down here that gets changed because you're going to want to change this as well to make that a plus, and then change this to negative 4x, a positive 17x, and a negative 36. So now when you start combining, this positive 2 and this negative 4 gives you negative 2x squared. So you know right away it's got to be one of these. And then my next one is negative 5x and positive 17 is going to give you positive 12x, which is this guy right here. I can stop after that. So now flip to the next page and try that last problem, I believe. Try that last one. So pause your video, try it, make sure you notice that this is the word from, and then unpause it when you're good. Alright, so I'm starting off with this. I'm going to be super lazy and just go like this. 4x to the third plus 4x squared plus 6. I'm going to draw the lines down to help separate all my terms so I'm nice and organized and I don't chop off any signs or have any questions. I have a keep, a change, and a change. So let's change all three of these. My biggest degree out of all these is x to the third, obviously. So I have a negative 4x to the third. That's the only ones. I have two different sets of x squareds. So if I have a 14 and a minus 4, I have a positive 10x squareds. That negative 7x can just be dropped down. And a 3 and a negative 6 brings me a negative 3. And that's it, guys. Some final thoughts. When subtracting, we're using two things we already know how to do. Adding polynomials. And that whole keep, change thing. I used to say add a line, change a sign. LeClaire says keep, change, so we're going to use that. When subtracting polynomials, you change all the signs after the minus sign. After, not before. That's where the word keep comes in. When adding, all you're doing is combining some like terms. Remember, like terms need to have the same letter and same exponent. You cannot put an x to the third with just a regular x. Those two don't go together. All your final answers should be in standard form. Again, that's in decreasing value by degree. Thank you so much for watching.